Hey guys, today we're going to be talking about additive and multiplicative relationships. And so we're going to start with an additive relationship, and we have this equation here that says y equals x plus 3 and 3/100. Okay, so what I'm going to be doing is I'm going to be using this equation as my rule for completing my input-output table. So my input is always going to be my x, and my output is going to be my y. Okay, so if you notice, my input can be any numbers that either they give us or you can create yourself. Okay, so for this example, we have 9 and 3/10, 9 and 5/10, 13 and 9/10, 13 and 2/10. Okay, so what I'm going to be doing is I'm going to be using this equation as my rule. Okay, so remember, we have 9 and 3/10 plus 3 and 3/100. Okay, so what I have to do is I'm going to have to solve for that. And this is where it gets tricky. You need to make sure that whatever they give you, you are following the rules. So here, if I'm adding decimals, then I need to line up my decimal place value. Okay. So remember here, I need to add a 0 because I don't have a 0. So we're gonna get 3, 3, bring down your decimal, and then 12. So my output would be 12 and 33/100. Okay, so let's do it for the rest of the table. This time I'm going to start with 9 and 5/10 plus, again the rule is the same, 3 and 3/100, and we're going to solve. 9 and 5/10 plus 3 and 3/100, and we add. Always line up your place values. So we get 12 and 53/100. Let's keep going. 13 and 9/10 plus, again, 3 and 3/100. Whoops. The 0 goes first, then the 3. So we're going to add your 0. So 3, 9, bring down your decimal, 6 and 1. 16 and 93/100. And the last one, 13 and 2/10 plus 3 and 3/100. 13 and 2/10 plus 3 and 3/100. Add your 0 again. 3, 2, bring down your decimal, 1. So my output would be 16 and 23/100. Okay, so we're going to have our inputs and we're going to have our outputs. Okay, now let's try it with multiplication. So I'm going to erase this, and we're going to do a new input-output table. Okay. All right, so this time my equation is going to say 0 and 7/10 times x. Okay, so this is a multiplicative relationship. Okay, so remember, our input are either going to be given to us or you can make them up yourself. Okay, so here they are. And so remember, this is multiplicative, which means the rule is going to be multiplication each time. Last time we were adding the same number each time. Now we're multiplying by the same number each time. So let's start with the first input. We have 20 times 0.7 tenths, okay? So when I multiply decimals, does it matter that I line up my decimal? It does not. So I just have to multiply 20 times 0.7, okay? I don't need to include the 0 in the ones place, okay? So we're gonna have 0, 14, and then we have 1 place value, so we're gonna move the decimal over once, which means my output would be 14, okay? Let's try the next one. We have 25 times 0.7, okay? So we're gonna multiply here. 25 times 0.7. Again, we don't have to line up our place value. So we have 7 times 5 is 35. Carry the 3. 7 times 2 is 14, plus 3 more. 17. And again, don't forget to put your decimal in the right place. So we have 17 and 5/10, okay? Now we have 30 times 0.7, okay? So 30 times 0.7. Now here you can use the power of 10, okay? And just multiply 3 times 7 is 21 and add the 0, and then still put your decimal in the correct place. So 21 would be correct. And then finally we have 35 times 0.7. So we're going to multiply 35 times 0.7. So we're going to get 7 times 5 is 35. Carry the 3. 7 times 3 is 21, plus 3 more is 24. And again, put the decimal in the correct place. So our output would be 24 and 5/10, okay? So remember, when you have a multiplicative relationship, we are multiplying, the rule is multiplying the input by the same number each time in order to get your output. When we have an additive relationship, we are adding by the same number in order to get our output, okay? Now, let's try. This time we're going to not be given the rule. Let's say that they just give you the table, okay? So I'm going to erase all this, and we're going to do this problem right here together. So I know it's a little hard to see, so I'm going to make it bigger for you guys. All right, so let me fix some of this, and then I'm going to fill in the table with the numbers that they gave us, okay? So they're telling us that we have 176, 225, 1,000, and 1,299. Then we have output, which is 88. We have 112 and 5/10. We have 500. And then we have 649 and 5/10, okay? All right, so they give us the input, they give us the output, and we have to figure out which of these equations would be, and I'm going to write them bigger here. So we have y equals 0 and 5/10 times x, y equals 5x, y equals 0 and 2/10 times x, and y equals 2 times x, okay? So we have to figure out which of these four is the rule, okay? So what I would do is I would use process of elimination, okay? So first let's look at our numbers that we have here. We know that our input is obviously greater than our output, okay? So 176 is greater than 88. 225 is greater than 112.5. 1000 is greater than 500, okay? 1299 is greater than 649.5, okay? So we know that these are greater, okay? So let's look at our equations here. We have all of them are being multiplied. They're all multiplication. Now we know that when we multiply, the number usually gets bigger, okay? So there's a catch, okay? When we multiply by a decimal, does the number get bigger? No. But when I multiply by a whole number, does the number get bigger? Yes, okay? So we can automatically eliminate our whole numbers because we know that if I multiply 176 times 5, I will not get a smaller number of 88. I will not. Same thing, if I multiply 176 times 2, I will not get a smaller number of 88. I won't. It's going to make it bigger. So now we've already eliminated two of them and we are down to these options. So now we can go ahead and work out to see which one would be correct. So I'm going to do 176 times 0.5 and 176 times 0.2 and see what I get. All right. So here we have 6 times 5 is 30, carry the 3. 5 times 7 is 35, 36, 37, 38. Carry the 3. 5 times 1 is 5, plus 3 more is 8. So again, don't forget we got to put our decimal back over one time. So we're going to put it right here. Then we have 176 times 0.2. So 2 times 6 is 12. Carry the 1. 2 times 7 is 14. Plus 1 is 15. Carry the 1. 2 times 1 is 2. Plus 1 is 3. And again, we move our decimal over once. So we get 88 here. And then 35 and 2/10 here. So the one that matches my output is this one. So this is the correct rule, okay? Which means that I would be multiplying each of these numbers by 0.5, okay? So if you notice, when I multiply by 0.5, it's the same thing as if I'm cutting it in half, okay? I'm cutting it in half. Half of 176 is 88. Half of 225 is 112.5. Half of 1,000 is 500. And half of 1,299 is 649.5, okay? All right, so let's do one more similar to this one, just so we can get some practice in. Okay, so let's erase these and we're gonna fill them in with new numbers, okay? Okay, so this time we have 1.5, 1.79, 5.7, 5.07, and then over here my output is 5.7, 5.99, 9.9, and 9.27, okay? So here are the options that we have. Y equals 4.2 times x. Y equals 5.7 times x. Y equals x plus 4.2. And y equals x plus 5.7, okay? So this one is actually a little bit trickier because we know that all of these numbers are being increased, okay? They're getting bigger. 5.7 is bigger than 1.5. 5.99 is bigger than 1.75. 9.9 is bigger than 5.7. 9.27 is bigger than 5.07. So I know that I can increase my number by multiplying or by adding. So technically all four of these could be correct. So we are not able to eliminate anything yet. We will need to use process of elimination, okay? So let's start with the first one up here, okay? So I would need to multiply 1.5 times 4.2 to see if I get it correct. So let's do that. I'm going to have to erase some of this and then we'll write it back up. Okay, so let's do it. 1.5 times 4.2. Okay, here we go. 2 times 5 is 10. Carry the 1. 2 times 1 is 2. Plus 1 is 3. Now, we got to drop our 0. Cross this out. 4 times 5 is 20. Carry the 2. 4 times 1 is 4. Plus 2 more is 6. And then we add. 0, 3, 6. Now we have 2 place values, so we're going to move it 1, 2 times. And we get 6.30, or you can also do just 6.3. So does this match my output here? It does not, which means this is not going to be correct. Okay, so I can eliminate that one already. So let's try the second equation that we have, which was y equals 5.7x, okay? So this time, we're gonna have to multiply 1.5 times 5.7. Let's see if that works. 1.5 times 5.7. Okay, 7 times 5 is 35. Carry the 3. 7 times 1 is 7, plus 3 more is 10. Drop your 0. Cross this out. 5 times 5 is 25. Carry the 2. 5 times 1 is 5, plus 2 more is 7. And we add 5, 5, and 7 plus 1 is 8. And again, we have 2 place values, so we're going to move it 1, 2. So we get 8.55, which again does not match the output that I have here. So that is not going to be my answer either. All right, so let's try an addition. We're gonna have y equals x plus 4.2. So this time the rule will be addition. We will have to add 1.5 plus 4.2. So let's see if it works. 1.5 plus 4.2. 5 plus 2 is 7. Bring down your decimal. 4 plus 1 is 5. And see how 5.7 matches the output as 5.7, okay? So we have found our rule. This is the equation that I can fill in. So 1.79 plus 4.2 will give me this. 1.79 plus 4.2. Oops, no, that's wrong. Sorry about that. 5.7 plus 4.2. And then 5.07 plus 4.2. Now, let's just double check that the last one that we did not work. So the last one was y equals x plus 5.7. So if we add this 1.5 plus 5.7, there's no way that I would get 5.7 because I'm already adding it, but let's just check. So 7 plus 5 is 12. 5, 6, 7, so we get, here we go. So see how it doesn't match. So we can eliminate this answer as well. All right, so again, input-output tables can be additive or multiplicative, okay? And the tricky thing is not when you have whole numbers, but when you have fractions and decimals like these, okay? So you got to make sure that you always apply the rules that you learned when you add or subtract or multiply fractions and decimals, okay? Thank you.